Welcome to PreMath. In this video, we have got this yellow shaded right triangle along with this circle with the center O fully inscribed in a blue square, as you can see in this given diagram, such that the area of this yellow shaded triangle has been given to us as 216 centimeter square. And moreover, the area of this blue square is 576 centimeter square as well. And now our task is to calculate the radius of this given circle. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's focus on this blue square ABCD. And we know the area has been given to us for this blue square as 576. And now let's recall the area of a square formula, area equal to S square, where S represents the side length of the square. So let's go ahead and fill in the blanks in this square area formula. So we are going to have S square equal to 576. I'm going to undo this square by taking square root on both sides. So therefore, the side length S of this blue square is going to be 24 centimeter. So thus the blue square side length turns out to be 24. So therefore, this side length is going to be 24, 24, 24, and 24 across the board. And here's our next step. Let's focus on this yellow shaded right triangle ABE. And now let's recall the area of a triangle formula. Area equals to a half times the base times the height. And in our case, the base of this triangle ABE is this BE side. The height is 24 and the area of this triangle is 216. So let's go ahead and fill in the blanks in this formula. So this is going to give us 216 equal to a half times our base is BE times our height is 24. Now we are going to divide both sides by 12, and this 12 and 12 is gone. So therefore our BE side length turns out to be 18 centimeter. So therefore this side length BE is going to be 18 centimeter. And now let's make an observation. We can see that this whole side length BC is 24. This segment BE is 18. So therefore this remaining segment EC is going to be 24 minus 18 is going to give us 6 centimeter. And now let's focus once again on this yellow shaded triangle. Now let's recall the Pythagorean triplets 3, 4, 5. If we multiply across the board with each and every number by 6, then our new set of these Pythagorean triplets are going to be 18, 24, and 30. We know this number is 18, 24. So therefore this hypotenuse has got to be 30 centimeter. And in this next step, I'm going to connect this center O with these points of tangencies P, F, and G. As you can see in this next step, I have connected all these points. And now let's make an observation. We can see this OP is the radius of this circle. So I'm going to label this one as lowercase r. Likewise, OF is going to be the radius lowercase r, and OG is lowercase r as well. And now let's recall the circle theorem. The angle between the radius and the tangent will always be 90 degrees. So no wonder all these angles are going to be 90 degrees each, since these are our radii and these are our tangent lines. And now let's make an observation. We can see this tiny square FCGO is indeed a square. And we know this side length FC is same as this side length OG. If this side length is radius r, then this FC length is going to be lowercase r as well. And in this next step, I'm going to connect these vertices A and C, as you can see in this next step. And that will be going through this center O for sure. And now let's make an observation. We can see that this AC is the diagonal of this big blue square ABCD. And likewise, this OC is the diagonal of this tiny square FCGO. Before we proceed any further, let me go over the basic concepts. And let's focus on this square whose side lengths are lowercase a across the board. And moreover, this is the diagonal of this square. Then the diagonal length is always going to be a times square root of 2 units. Now let's focus on this big blue square ABCD whose side lengths are 24 and 24 across the board. So therefore, its whole diagonal AC is going to be 24 times square root of 2 centimeter. And now let's focus on this tiny square FCGO whose side lengths are lowercase r and lowercase r. So therefore, its diagonal OC is going to be r times square root of 2. And now let's make an observation. We know this whole AC length is 24 times square root of 2. And this OC length is r times square root of 2. So therefore, this segment AO length is going to be simply this 24 times square root of 2 minus this length r times square root of 2. And here we can see square root of 2 is in common. So therefore, this segment AO length is going to be square root of 2 times 24 minus lowercase r. So thus our this segment AO length turns out to be square root of 2 times 24 minus r. And now let's make an observation. We know this whole segment EC length is 6. This FC length is lowercase r. So therefore, this remaining tiny EF length is going to be 6 minus r. And now let's recall the two tangents theorem. According to this theorem, if two tangent segments are drawn to one circle from the same external point, then they are congruent, as you can see in this given diagram. And here we can see these two segments AO and this segment BO are equal. And now let's focus on our this given problem. We can see this AF and PE are our two tangents and they are equal. If this segment is 6 minus r, then this PE segment is going to be 6 minus r as well. And now let's make an observation. We know that this AE length is 30 and this tiny PE length is 6 minus r. So therefore, this remaining AP length is going to be 30 minus 6 minus r. Let me just write it down over here. 30 minus 6 minus r. And now let's go ahead and open up this parentheses. So therefore, we can write this one as 30 minus 6 plus r. So therefore, our this AP length turns out to be 24 plus lowercase r. So thus our this segment AP length turns out to be 24 plus r. And now let's focus on this right triangle APO. And we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our two legs are lowercase r and 24 plus r. And our hypotenuse is square root of 2 times 24 minus r. Let's go ahead and fill in the blanks in this Pythagorean formula. So we got r square plus 24 plus r whole square equals to square root of 2 times 24 minus r whole square. And now we can see this square and square root onto each other, so we are ended up with 2 outside, as you can see in this next step. And now let's recall this famous identity, a plus b whole square could be written as a square plus 2ab plus b square. We are going to apply it on this left hand side of this equation. So therefore left hand side going to be r square, and then we're going to apply the identity. So that is going to give us 576 plus 48 times r plus r square is going to be equal to, and now let's recall another identity, a minus b whole square could be written as a square minus 2ab plus b square. We are going to apply it on this binomial on the right hand side. So therefore this could be written as 2 outside, and this is going to be 576 minus 48 times r plus r square. And now we are going to combine these like terms on the left hand side, as you can see in this next step. And in this next step I'm going to divide both sides of this equation by 2, and here we can see 2 and 2 cancels out. So when we divide by 2 on the left hand side, that is going to give us r square plus 288 plus 24 r equal to 576 minus 48 r plus r square. And now we can see this r square and this r square, they are gone. And now I'm going to move this 288 on the other side, and at the very same time I'm going to move this negative 48 in the opposite direction, as you can see in this next step. Now that is on the left hand side is going to give us 72 times r equals to 288. And now we are going to divide both sides by 72 to isolate radius r. We can see this is gone. So therefore our radius lowercase r turns out to be 4 centimeter. So thus after all the manipulations and calculations, the radius of this circle turns out to be 4 centimeter. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.